Hello my dear students, let us take some more examples on bending stresses in the beams. Okay, let us take this example. A cantilever beam is rectangular in section having 80 mm width and 120 mm depth. If the cantilever is subjected to a point load of 6 kN at the free end and the bending stress is not to exceed 40 MPa, find the span of the cantilever beam. Here it is a cantilever beam and it is given a section of 80 mm width and 120 mm depth. So it is a rectangular cross section and it is subjected to a point load of 6 kN at the free end. Okay, bending stress is given. It should not exceed 40 MPa. You have to find the span of the cantilever beam. Okay, so width is equal to 80 mm and depth is equal to 120 mm and point load is equal to 6 kN, that is 6 into 10 raised to 3 Newton, and bending stress is 40 MPa or 40 Newton per millimeter square. So this is the cantilever beam, okay, and this is the cross section, rectangular cross section, and load is acting at the free end of 6 kN. Now what you have to calculate? You have to calculate the length. So we have the equation m divided by I is equal to sigma divided by y, or you can write in terms of sigma. Sigma is equal to m into I divided by y. I divided by y, that is ratio of moment of inertia to the extreme fiber, that is equal to z, section modulus. So sigma is equal to m divided by z. You can write like that. So first we have to calculate what is z, that is section modulus. This is a rectangular cross section, so z is equal to BD square divided by 6. Okay, so what is B? B is 80 and D is 120 square divided by 6. So you get z is equal to 192 into 10 raised to 3 mm cube. Okay, next we will see what is m, okay, moment of resistance, okay, or bending moment. So this is given in the problem that maximum bending moment at the fixed end of the cantilever subjected to the point load at the free end, means it is given here the point load at the free end is 6 kN. So you have to calculate what is the maximum bending moment. What is maximum bending moment? You have studied this in shear force and bending moment diagram for the cantilever beams. When the load is acting at the free end, the maximum bending moment is given by the equation m is equal to W into L. Okay, that is at the fixed end. So what is W here? W, it is given 6 into 10 raised to 3. L we don't know, that we have to calculate. We have the formula sigma is equal to m divided by z. Okay, why this is because we have the equation m divided by I is equal to sigma divided by y, right? Here sigma is equal to m, sigma is equal to m into y divided by I. Right, sigma is equal to correct, no? Sigma is equal to m into y divided by I. We know that I is equal to, or we can write m is equal to, means this if you write in terms of like this, m is equal to I into sigma divided by y, or you can write like this also, m is equal to I into sigma divided by y, correct? M is equal to I into sigma divided by y. This I divided by y, that is nothing but z, so m is equal to z into sigma, or sigma is equal to m divided by z. Okay, that's why it is written here 40, that is bending stress is given. 40 is equal to m divided by z. M is equal to this value 6 into 10 raised to 3 into L divided by Z. Z is 192 into 10 raised to 3, that is equal to, when you simplify this, you get L divided by 32. So here 40 is there, so 40 into 32, that is equal to L, so that is equal to 1280 mm or 1.28 mm. So this is the length of the span. Okay, like this you can calculate what is the length of the span when it is subjected to a point load at the free end when the beam is cantilever. Okay, so next take one more example. A hollow square section with outer and inner dimensions of 50 mm and 40 mm respectively is used as a cantilever of span 1 meter. How much concentrated load can be applied at the free end of the cantilever if the maximum bending stress is not to exceed 35 MPa? Okay, here this is a square section, hollow square section. So it is given outer depth, that is equal to width also, equal to 50 mm. This outer width or depth is equal to 50 mm and inner width or depth is equal to 40 mm, and span is given, that is 1 into 10 raised to 3 mm, means 1 meter, and maximum bending stress is 35 MPa or 35 Newton per millimeter square. You have to calculate what is the load, concentrated load. This W you have to calculate at the free end of the cantilever. Again, this is also cantilever beam. Okay, so what we'll do first, we will calculate what is I, moment of inertia. So moment of inertia for a hollow rectangular section is capital BD cube divided by 12 minus small BD cube divided by 12. Now this is a square section, so both the breadth and depth are same. So what you can write, B into D cube is, that is B, or you can write B into same BB cube, okay, or DD cube, anything is fine, no problem, because both breadth and depth are same here. So BB cube divided by 12 minus small BB cube divided by 12, or DD cube divided by 12 minus small DD cube divided by 12. So that is B raised to 4 divided by 12 minus small b raised to 4 divided by 12. Substitute the values, 50 raised to 4 divided by 12 minus 40 raised to 4 divided by 12. Okay, when you simplify this, you get I is equal to 307.5 into 10 raised to 3 mm raised to 4. Now you can calculate what is section modulus Z. Z is equal to I divided by Y, moment ratio of moment of inertia to the distance of extreme fiber from the neutral axis. Okay, what is I? I is 307.5 into 10 raised to 3 divided by Y. Y is, this is a rectangular section, right here, hollow square section. So the Y is equal to exactly at the center, that is 50 divided by 2, that is equal to 25. So substitute that 25, you get 12300 millimeter cube. This is section modulus. Now what we have to calculate? We have to calculate W. So what is the formula here? This is a cantilever beam and subjected to the point load at the free end. So maximum bending moment will be at the fixed end, that is equal to W into L. W we don't know, we have to calculate into L is equal to 1 into 10 raised to 3. So when you simplify this, you can write 1 into 10 raised to 3 W. Okay, now we have that formula, sigma is equal to m divided by z. Sigma is equal to 35 is equal to m is 1 into 10 raised to 3 divided by z is 12300. Simplify this, you get W is equal to 430.5 Newton. Okay, this is in Newton because all other terms are in Newtons only. So W is equal to 430.5 Newton or 4.3 kilonewton. Okay, so in this way you can calculate what is the W. Okay, let us take one more example on a hollow steel tube having external and internal diameter of 100 mm and 75 mm respectively is simply supported over a span of 5 meters. The tube carries a concentrated load of W at a distance of 2 meters from one of the supports. What is the value of W if the maximum bending stress is not to exceed 100 MPa? Again, here also in this problem it is asked to calculate what is the concentrated load of W, what is the value of the load W. Okay, and here it is given that W is located at a distance of 2 meters from one of the supports. Suppose if it is 2 meters from this support and it is 3 meters from the other support, because total length is 5 meters, it is given span. So at a distance of 2 meters from one support and distance of 3 meters from the other support. Now here this is a hollow steel tube. So external diameter is 100 mm, internal diameter is 75 mm, and span is given, and this is distance it is given, I have written here, and maximum bending stress is equal to 100 MPa or 100 Newton per millimeter square. So first let us calculate what is M. Okay, if it is a this is not mentioned whether it is a cantilever, it is a simply supported beam, it is given here. So in the case of simply supported beam, when there is a eccentric load, okay, this is eccentric load, the maximum bending moment is given by the formula M is equal to WAB divided by L. Okay, here M, so write in like this, M is equal to, this is the standard formula, okay, for the eccentric load. In the case of simply supported beam, maximum bending moment will be given by WAB divided by L. W we don't know, we have to calculate, into A is 2 into 10 raised to 3 distance, this distance is A and this distance is B. Okay, so that A is 2 meter and B is 3 meter into 10 raised to 3 because it is in millimeters, divided by 5 into 10 raised to 3, 5 meter, that is 5 into 10 raised to 3 millimeter. So that is equal to 1.2 into 10 raised to 3 W. Okay, now we have section modulus Z. Z is equal to the formula is pi divided by 32D into D raised to 4 minus small d raised to 4. Substitute the values. Diameter, capital diameter is 100 raised to 4 and small diameter is 75. Simplify this, you get Z is equal to 67.1 into 10 raised to 3. Now what we have to calculate? We have to calculate W. So we have the formula M divided by I is equal to sigma divided by Y, or if you write in terms of sigma is equal to M divided by Z. So write that sigma, it is given 100 is equal to M. M is equal to 1.2 into 10 raised to 3 W divided by Z. Z is 67.1 into 10 raised to 3. So you get W is equal to 0.018. Now into this 100 is there, that is the simplification. So W is equal to 100 divided by 0.018, that is equal to 5.6 into 10 raised to 3 Newton or 5.6 kilonewton. Okay, so like this you can calculate the W for the different cases. Suppose if it is given simply supported beam at the center, or simply supported beam with the UDL, or simply supported beam with the eccentric load, or cantilever with the free end at the center, or free load at the load at the free end and UDL. So mainly you have to know what is the maximum bending moment formula. So if you have that formula, you can write what is maximum bending moment in terms of W. Then you have to calculate section modulus, that is different for different section, for rectangular section, circular section, and hollow rectangular section, hollow circular section. You should know all the formulas. Once if you know Z, you can directly substitute in the formula sigma is equal to M divided by Z. So you will get what is the value of W. So if you know M divided by is equal to sigma divided by Y, you can answer any question asked in terms of, it may be a W, it may be L, or it may be sigma, anything. Okay, I hope all of you understood. If you have any difficulties, we can discuss in the class. Thank you.